Good morning to one and all. In the third unit of high voltage engineering, we are now going to see generation of high voltages using resonant transformer. Hope you might have studied the concept of resonance in your circuit theory. The same property is now being applied to secondary of transformer and available for generation of high voltages. Let us go through the video.
Equivalent circuit of high voltage testing transformer or resonant transformer. It consists of reactance reactance of the winding or winding resistance, magnetizing reactance, and then capacitance. That this capacitance may be the output terminals, this across the output terminals due to bushing, and it may be also due to that test object. So for any resonance condition, we need resistance, reactance, and capacitance. So all three parameters are there in transformer. So this is the equivalent circuit of resonant transformer. This is AC supply, a simple transformer, AC supply. Then this is reactance, reactance of winding. Then this reactance and this capacitance. So then if we will further simplify it, or we will draw the equivalent circuit. So this will be the supply, reactance, resistance, reactance, resistance, reactance, and capacitance. This is the shunt branch. In general, when we used to draw the equivalent circuit, then we used to neglect this one. So R, L, and C, these three components are there. So at resonance condition, when XL is equal to L XC, at that time only R will be there. So it is possible to have series resonance when this frequency is equal to, when XL is equal to XC. So with this condition, the current in this case XL will be due to this L1, L2, and L combination of this L1 and L2. So with this condition, current in the test object is very high and it is limited by the resistance only, and then voltage waveform will be purely sinusoidal. Now if we are calculating the voltage across the capacitance, so this VC will be equal to this I into XC, and I will be V upon Z. So V minus of JXC upon R plus JXL minus XC. We will further simplify because XL is equal to XC. So V by R into XC, it will be equal to V upon omega CR. R is the total series resistance. It is equivalent resistance. In the equivalent circuit, the R1 and R2 are given.
If it is your dream to work at a Mang company, all you need to do is register for this free masterclass on how to become a
Given, but this R is the total series resistance of the circuit. Now this factor XC by R is the Q factor of the circuit, and this Q factor, it gives the magnitude of voltage multiplication across the test object, and then condition will be the resonance condition. So input voltage required for the excitation is reduced by 1 by Q, and similarly kVA required is also reduced by 1 by Q. Secondary power factor of the circuit will be unity, because at the resonance condition power factor is unity. This principle is utilized in testing at very high voltage on such occasions which require large current output. And then example may be cable testing, dielectric loss measurement, or partial discharge measurement. There are some advantages of resonant transformer. It is able to produce high voltage and high current for extremely high voltage requirement. So cascading can also be done. Cascading of resonant transformer. Output waveform is purely sinusoidal. Power requirement is less, only 5 to 10% of total kVA, as it was already mentioned that power kVA requirement will be reduced by 1 by q times. Then kVA requirement will be 1 by q times. Design simple and compact. Safety: if the test object is failed during testing, then no danger is because of high power arcing and heavy current surge occurrence, because due to failure of test object, resonant will not be there. So safe, completely safe operation. In case of partial failure of test object, resonant will not be there and voltage across the test object collapse. Then no repeated flashover occur in the case of partial flash failure. The disadvantage is the choke requirement is a disadvantage. A simplified diagram for series and parallel, this is shown in upcoming figures. This is shown for series, a regulator, transformer, this inductance and the capacitance. This is excitation transformer. This is series resonant transformer, and this one is parallel. Now it is please see the difference between series and parallel. In parallel, this winding is connected at this point, and in series this winding is connected at this point. So the difference between series and parallel has to be noted carefully. In excitation transformer is connected at this point, and in parallel excitation transformer is connected at this point. In parallel resonant AC system, a voltage regulator is connected to supply. Secondary winding of exciter is connected across the high voltage reactor and the capacitive load. This one. Secondary winding is connected across the reactor and this load. Inductance is varied. C this C capacitance is due to test object, capacitance of voltage divider, or capacitance of high voltage bushing, or maybe any other reason. Then advantage is more stable output voltage, high rate of rise of test voltage. The Q factor obtained in this circuit will be around 50. And the advantage of parallel resonant circuit, it is more stable output voltage can be along with the high rate of rise of test voltage, and a single unit resonant test system are built for output voltage up to 500 kV, while if resonant transformers are connected in cascade, then they can generate up to 3000 kV. So thanks for watching this video. In the next video I will discuss about the Tesla.
So in the next video we will be seeing about the Tesla coil. So thank you so much.